So welcome to today's HiveMQ webinar. I'm Allison Irungaray, Chief Marketing Officer here at HiveMQ, and we have a really great session planned for you. It's a panel discussion on accelerating industrial AI in 2026. You can think of this like a fireside chat. We want it to be fluid, no slides, and we'll take your questions, of course, at the end. So please start to enter those questions in the chat as soon as they come to you. The reason we decided to bring together with this panel is because we are hearing a lot of our customers saying this, saying they're being asked to do something with AI, whatever that might mean, different things to different people, to different companies in the industrial space. So HiveMQ, we completed a survey with IIoT World of almost 300 individuals, and we asked about this. We asked about their readiness, asked about their progress with AI, how they're thinking about it, what benefits they expect to get from AI use cases, and kind of what that journey looks like over the next few years. And so we're going to frame this conversation today around the results of that survey. We brought together a really great group. All of these individuals and the companies they represent are helping customers who have these challenges, who are working to establish the right foundation and then build AI use cases on top of that foundation. So let's start with Travis and then John and Magnus. If you can introduce yourselves, that would be great.
Well, everybody, thanks for having me, Allison. My name is Travis Cox. I'm the Chief Technology Evangelist here at Inductive Automation. I've been with the company for 22 years. And over those years, I've been working very closely with customers and integrators to help them with their architectures and putting together solutions that goes beyond just what Ignition does with our software platform. But we're really trying to lay that right foundation on the OT so that we can enable technologies like AI and other things to just be easier to accomplish.
Great. John?
Yeah, thank you, Allison, and thank you to Hive for number one, creating this or getting this survey done, and number two for hosting the webinar, inviting me to join Magnus and Travis. Always fun to talk with two other or three other people who know the industry so well. So I'm the Chief Product Officer at HighByte. I've spent my entire career building solutions and technology for manufacturing and around manufacturing. Some of the time working in a manufacturing company, most of it working on the technology solution side. HighByte is a software company focused on industrial data ops solutions. I'm sure we'll hear more about that and about around data, but I spend a lot of time thinking about data and how we can leverage it around AI and other digital transformation initiatives. So nice to be here.
Great. Thanks, John and Magnus.
Thank you, Allison, and thank you, Travis and John, for joining us. I'm Magnus McCune, VP of Product Strategy and New Product Incubation here at HiveMQ, working to understand the needs of our customers and working to augment our platform to meet those needs as best as possible. So whether that's in the data streaming layer and data movement layer, whether that's in data intelligence and contextualization, or moving into agentic AI and operations around that. Thank you.
Great, thank you. Really excited to bring this group together. It's maybe taken us a little bit too long, but three great minds in the industry that are working with customers on daily on very similar problems. So excited to talk to all of you. So let's start out talking a little bit about how expectations around AI have shifted. The last few years, AI has really been a buzzword. It's no longer a future experiment, right? It's now expected to become part of how operations run. In the survey that we did with IIoT World, 67% of respondents are interested in agentic AI and autonomous operations. No surprise there. 44% of them expect AI to be embedded in not some, but most of their core processes within 3 years. So that's a pretty high number. Almost half expect AI to be embedded in their core processes. There's a lot of work that has to be done to get there, and that's what we're going to talk about today. So let's talk about how those expectations have shifted recently. Travis, we'll start with you. What do the customers that you're working with expect AI to do now that they perhaps didn't expect a few years ago?
Yeah, well, first of all, AI is now more accessible than ever. As the technology has evolved, it's easier for people to get started. It doesn't have a huge gap in terms of what they need to know in order to bring these systems into their facilities. But it's all about moving beyond, the simpler tasks. Historically, for a long time, A lot of people were, implementing ML, machine learning, within their systems, and now that's going, of course, more to agentic AI, right, to those autonomous operations, and especially around predicting failures and performing optimization, which you see a lot in that in the survey results. One big shift, though, is that historically we would have had data scientists who would move data from systems into other platforms or other data warehouses so that we can actually then build models off of that and run those back run the inference back on the edge or wherever. Well, now we're looking at connecting AI directly to these live systems, and MCP has been a big help in being able to do that, so that we can get the full context and get information right away without having to actually go and do a lot of the movement and the mappings that are there. It's also all about augmenting human capability these days, especially operators, so they can ask natural language questions about the current state of their systems and get really good insights of that and how that can adapt and learn over time. And we also expect AI to help us actually build our configuration and help us build our projects. That the generative AI space is really exploding, and it's actually really good. I mean, with Ignition in particular, I can go ask it to build me data models or a project of a certain type, and it does a really good job getting mostly there. And as that evolves even more, it's just going to help us especially get rid of legacy faster and get to modern systems, to take advantage of all that we have here.
Thank you. That's a great way to kick us off. As you spoke, I thought we could talk the whole hour about AI moving to the edge and changing the way that we do things on that side, but really good description of how we've moved from upstream, downstream, right, with AI. So, John, let's go to you a little bit. So, when AI is expected to be embedded across operations, not just as Travis talked about in the data warehouse, what changes in how teams need to think about the architecture that they're building to support that?
Yeah, it's an important question. When I think about industrial architectures, I think most people start with a network architecture. And network architectures are generally put in place for security concerns and for efficiently moving and connecting systems. And then we start to think about the ISA 95 architecture of the different layers of applications. So that's really an application architecture that's focused around the function that needs to be performed and the time scale. But I think one thing that people haven't traditionally thought about that they need to start thinking about now is the data architecture. And as Travis said, we're running AI at the edge, we're running it in the data centers, we're running it in the cloud. And AI, and this came out a lot in the survey, AI needs data, and data is the big challenge. And it needs well contextualized and curated data. So what we're seeing is that successful companies are starting to think about we've got a network architecture, we've got a application architecture, but we need a data architecture, and we need a data strategy, and we need data infrastructure so that we can scale these things out. And that's really one of the big changes and one of the big focuses. I think it came out some in the survey, and we're seeing it where people are starting to think about data as a much higher level concept. And this is where industrial data ops really came out of, is how do we think and put infrastructure in place to solve some of these data challenges? How do we orchestrate data efficiently across our different applications? How do we ensure high quality data and observability of that data? And then how do we govern it? And how do we build we've been thinking a lot about this concept of data products because it's not just about a single data point. Industrial is generally thought about individual tags or individual data points. It's really about creating these data products that are data sets that are all related and add context and curation to that data. So, I think that's where companies really need to start thinking about evolving their architectures to really have data as a first-class citizen, and it really starts to solve some of these data problems when they do that.
Thank you. So Magnus, I was going to shift a little bit, but anything you'd like to add to what Travis and John said first? I feel like it's very consistent with what you talk about it, where the data is moving, where AI is moving, if you just have anything to add on there.
Yeah, I mean, I think the core piece here is the foundation is required in order to scale AI. So, as we're looking to scale the use cases for AI, those foundations, both that data architecture and the technological foundations, are really key here. So, whether that's quality, availability, governance, context, they're what make industrial AI repeatable. And getting those right is the sort of first order thing before we can move, beyond where we are today. The first order thing is getting those foundations right. So that's we have great foundations in enterprise historically for things like data warehouses and what some refer to as an enterprise data platform. We need to shift that concept to include real-time data and to include operational data.
Thanks. And then the other thing I was going to ask you is, as I mentioned the survey at the beginning, almost half of our respondents said they plan to embed AI as most of their core processes. So what does that actually mean in practice? I mean, you're talking to customers that are trying to move in this direction. What does that mean?
Yeah, I mean, to me, AI in core processes means it's embedded in the day-to-day operational decisions. So whether that's maintenance and predicting failures, like Travis mentioned, things around product quality or manufacturing quality, energy usage, throughput, and not just as a pilot project, right? It's really embedding that into day-to-day operations. As you mentioned, there's a lot of work for us to get there, and building those foundations is a part of that. And the other piece is it needs to be measurable. So if we're changing how facilities run and using AI to improve how facilities run, we need to be able to prove that impact. We need to be able to demonstrate that we're making progress effectively. And so measurability is a key part of this, I think. And as we get into this idea of moving away from AI as something fancy and new to something that is just part of our reality, being able to measure how that shift is going is a really key part of that. And of course, as we were just saying, the prerequisite is trusted, contextualized operational data. Otherwise, you're just sort of automating guesses. You're not building on the right foundation.
Okay, that bridges us perfectly to what we're going to talk about next, which is, optimism versus execution. People are excited, but how is the execution going? So most organizations aren't there yet. That's probably not a surprise to the panel or anyone on the call, but from the survey, we're seeing this in practice too, right? But the survey specifically said only 7% of the respondents say AI is embedded in core processes right now. 36% are still running pilots or POCs, right? So as I mentioned, though, in 3 years, they expect to be much further along in that process. So no big surprise there, but let's talk about how companies tend to underestimate getting from point A to point B. I think that's where a lot of roadblocks are happening right now. So, John, we'll start with you. What assumptions do you see some of the customers that HighByte works with that you talk to? What assumptions do you see teams making about scaling AI that then don't end up holding up in practice?
Yeah, a lot of AI projects are sitting today in the IT team to implement. So the business comes down and says, we need a project that utilizes AI for this purpose. And the IT team gets handed that and they try to go off and solve it. And typically in large companies, AI or the IT team is used to working with monolithic systems. So like an ERP system and a CRM system. And we've only got one ERP system for our entire enterprise in some cases, or at least for one site. We have a ERP system and maybe it shares across um, a broader organization. Um, when you get into the industrial world, it's not that way. It's not that way at all. It's very fragmented. And so a lot of times they come in, the IT team comes in and they're saying, we want to implement AI, so we need access to data. And they start off by looking for what's the transaction system we could use or that monolithic system. And it could be MES. And then they realize, well, we've got multiple MES systems and we've got multiple SCADA and we've got lots of other data around here. And so it just becomes a real challenge to get access to that data. And then they realize there's no standards on that data, there's no context on that data. So how do we get going? So I think a lot of times IT thinks, oh, this will be easy. Let's just give us the data, and it's much harder than that. There's a lot more effort that needs to go into it in setting up that data. It's not impossible. In fact, there's a lot of great tools to do that, but it's more than what was expected. The other thing is that people think AI can just solve any problem. So not only can it solve my use case, but it can also solve my data problem, and we'll just AI everything and AI wash it. And AI is extremely powerful, and Travis had outlined a number of different areas where people are using AI, from machine learning to agents to writing code. But it takes smart people to be working with it and to set it up and to put it in place with the proper infrastructure in order to be able to scale this out. So, I think recognizing the challenge of industrial putting in that infrastructure is one area where people just don't think that's needed. I think that the survey highlighted that, and we continue to see that, and just um, but there are tools and practices that are coming online today that can help solve that. So it's exciting times.
Thanks. And Travis, maybe you can point to a few more specific places because similar question, where do you usually see that execution breaking down? So, yeah, I assume you see similar things to what John mentioned, but if you can dig into some of the specific places that these POCs fail to fail to scale, that would be great.
Yeah, I mean to build on top of what John said, like one of the biggest issues, right, is we don't just do AI to do AI. Like it is a big buzzword these days, and people want to do it and you want to bring it in, but you got to have the right business objectives or use cases that you want to use. And I think right now there's still a lot of, there's not a lot of clarity as to which ones people should be driving, right? And there is a lot of misalignment between the IT teams and the operations teams with this. I mean, we like what John was saying, like we live in a world where the reality is that customers, while we think of Industry 4.0, they're not even done with Industry 3. And there's a lot of data silos that are out there. There's a lot of different systems, and especially this facility to facility, there's a lot of different differences. No standards. A lot of data is not even accessible, and so that leads to can lead to a lot of problems. And you think like, oh, we're just going to come down and get access to that data, and we can just go off and do all these cool things. Well, if we neglect the actual foundations that we need to kind of the architecture changes and the foundation changes that we need to do, it becomes a really difficult task. And so I think where a lot of the acceleration, of adoption is falling down is just really kind of that lack of real leadership driving the culture around this and what people's roles are, with AI and being able to educate everybody as to how we're going to work together to accomplish those big business objectives. If you drive that first and say, hey, look, we're a company, we want to be Industry 4.0. This is we want to lead, the industry and do X, Y, and Z. And here's how we're going to approach that. We're going to leverage tools for it makes sense, and we're going to pick the right objectives, and we're all going to work together to solve those. When you have that kind of alignment, those are the companies that are going a lot faster and are able to recognize the systems that need to be upgraded or changed, and realize we can't do it all at once, right? We can't eat the whole elephant. We've got to take it in strides. We've got to move from legacy systems to modern architectures that allow us to actually enable AI in the right way. And I think this is the big piece that really has to be done and thought about. There's a lot of POCs that are happening. It's easy to put a POC in place, right? As John was saying, right? We can go and do that, and we shouldn't not do that, right? We should be able to kind of see and get our feet wet. But we then have to realize, okay, when we move past a POC to actual production and scaling, we have to be clear about how we're going to do that. And I think this is a big part of just and AI is still new, right? And there's a lot of unknown territory, and this is part of just navigating that. But the clearer you can make that trajectory, the easier it's going to be.
Okay, great. We had a question come in chat that I think is pretty applicable to what we're talking about now. So I'm gonna shift to Magnus. So Magnus, I want you to talk about what has to change in the minds of our industrial customers, companies that we're working with that can turn this confidence that they'll be able to do AI in the next couple of years into real execution, right? But what I want to bring in is someone asked in the Q&A, they're talking about how AI needs a lot of high quality data. The assumption is once given the data, the folks in IT will find uses for it. But the question was, how can we find small AI wins to get wind in our sails so that we can show ROI at all steps in the data maturity journey? So I loved that question and just thought maybe we can somehow tie it into how do you turn confidence into real repeatable execution and show small wins along the way that shows that the project you're working on is worthwhile and going to bring ROI to the company, right?
Yeah. No, I mean, I think it's a very apt question. So, I mean, there's sort of two parts to this. So, how to make the change to create confidence in generating repeatable outcomes. I think the key thing there is moving from this idea of individual segmented pilots that sort of are isolated projects into thinking of this as a platform. So, building that real-time data foundation, building those building data as a product. Creating that shared semantics that's required to sort of understand the data and understand the context around it, and create reusable use cases. And so to the person's question of how do I get small AI wins, my answer is the same as my answer would have been 3 years ago for how do I get Industry 4.0 wins, which is start building that data platform, but then also layer in use cases with really discrete, achievable goals, right? So an example from a customer who's been very successful in both their Industry 4.0 transformation and is starting on their AI journey is defining really discrete use cases for which they need a strong data foundation. In one case, it was energy efficiency, energy usage monitoring, and demonstrating that, hey, with this data foundation that we've now put in place, we can achieve wins around energy usage, and that's the same for AI as well, right? So define those early use cases, build with platforms in mind, build with scale in mind, but start with early wins that you can demonstrate to your leadership. And as both Travis and John shared, real-time data maturity is still quite uneven. I think there was a great statistic from the survey that we'll share that less than 34% of companies feel that they have a strong real-time data platform at the moment. So getting that built and starting to build use cases on top of that is key. And then, of course, common semantics and those data models that John Harrington spoke to earlier, the products, building data as a product. And then the cross-functional ownership, I think, is the other key piece here. Is this can't just be owned by IT. It can't just be owned by OT, or even a third category of IT, which I've described as data teams. It needs cross-functional ownership to ensure we're sort of driving towards positive results.
Hey, Allison,
Okay.
can I add one other thing?
Yes.
I think AI, so we're looking at AI projects in some ways similar to implementing a new MES system or a new SCADA system or a new MQTT broker or like a new system. And I think some companies actually have to take a step back, and it's not about a proof of concept, but using the concept of experimentation. So you almost have to experiment with the technology for a little while to find where it works well and where it doesn't work well before you do real proof of concept. Like, don't worry about, and if you think of it more as experimentation, then people can be much freer with really getting their hands dirty, feeling how it works, seeing where it can help and where it can't, and then they can do real proof of concepts. I think some companies are going at it and saying, let me immediately get started, and they don't even know when to use machine learning versus an LLM versus coding versus different types, all these different types. So if you're not familiar with it at all, I would consider more experimentation and then get into a proof of concept with a very defined use case and then start implementing. The technology is going to come around fast. The slowest part is actually the experimentation and the recognition of what applies where and what does really well where. LLMs are great at talking with humans. LLMs are not great at performing math calculations and stuff like that, but machine learning is great at that. So there's lots of tech out there. Start experimenting, and then you'll be able to, I think companies will actually be able to move faster when they get into real projects.
I couldn't agree more, John. Like, what are the right problems to use this technology to solve? I think it's still an open question. I don't think any of us on the call knows the answer, and from the conversations I've had with our customers, I don't think they yet know the answer either. And so that experimentation, I think, is really key. Yeah, what specifically as it relates to LLMs, I think machine learning we've made good progress on, but as it relates to large language models and agentic AI, yeah, what are the right problems to be trying to solve? And I think there's an academic approach that is happening of trying to be very rigorous about that, but I also think companies should experiment and see what can be solved.
And I'll add
There's a
one.
lot of,
Oh,
oh, go ahead,
sorry,
Travis.
Alice. I
Yeah.
was going to add one more thought, which is, we have seen time and time again where just being able to get data in the right people's hands, right, where it was non-existent before, has led to a lot of results, right? And that's the people that the operators or the people that are responsible, for making these operations run. And I think that that's a real interesting place to start is how can you make those people better? And give them more information, more tools to do their job in a way that will yield a lot of results because they're the ones running it day in and day out. And the more the more we can make them superhuman. It's not about replacing them. I think a lot of times we look at AI so far as like we're gonna just build these things that are just gonna magically give us results. And that can happen, right? But ultimately, if we focus on making the people that are running this just better, and I think right now there's a clear win for AI to do that. That's going to yield a lot of results, just like it did with getting data to the right stakeholders. So it's just a layer above that. So I think it's an interesting place, to think about.
Yeah, so there's a lot of questions in the chat. So I'm gonna save this for when we get to the Q&A section, but there's a lot of questions about use cases, right? OEE, let's talk more about machine learning. Can the panel, I can just feel that the audience wants the answers. Like what is AI good for and what is it not good for? So we'll save that and talk a little bit more about the data foundation, but I think that'll probably be a big part of our Q&A section is to have you each start thinking about some of those specific use cases that are good early wins and things like that. So we've already alluded to this, so let's jump into it. Like, what are the real data barriers to industrial AI? When we asked the survey respondents about AI adoption challenges, they didn't point first to models. And I also saw a question in the chat about this, like about asking about when you worry about models. They pointed to data. So 54% said data quality and availability was the biggest challenge, and 48% said integration with legacy systems. Obviously, we've heard Travis talk about that a bit as well. It's Inductive's area of expertise. So when people talk about AI ready data, and a lot of us, I think several of the companies on this call use that term frequently, and others in the market. What does that actually mean in practice? What is AI ready data? So Magnus, I'm going to start with you. Why is data quality and availability hindering AI use case adoption? What are some of the challenges that you're seeing there?
Yeah, I mean, ultimately, uh, as Travis put it, AI is an amplification tool, and it amplifies whatever you feed it. So if you feed it poor data, if you feed it inconsistent or uh, uh, insufficient data, it's just going to produce confidently incorrect answers. And truly in industry today, data is often incomplete, inconsistent, or trapped in silos or trapped in different sections of an organization. And so without uh, uh, those data products again that John was speaking to, without the context. A model can't really tell the difference between something that is faulted versus a machine that was intentionally shut down. It just doesn't have the context. It doesn't have the understanding. It doesn't have the reasoning to be able to do that. And so really that is where data quality and availability just matter is do I have sufficient amount of high quality data to reason over? I mentioned over the survey, over half of the organizations surveyed cite that data quality and availability is the top barrier for them to move ahead with these projects. So really, it's as John said, treat operational data like a product. Start by getting it moving, introduce standards, introduce validation, make those data products owned by specific individuals in the organization, and treat them the same way you treat a manufacturing product. Treat them like a product in your organization that you are producing and that needs to be high quality in order to get useful outcomes from.
And there's a question in the chat, Magnus, before investing in AI models, have companies already addressed the data fundamentals? So I'll just ask, are you seeing that to be the case or typically not?
I think it's all happening very fast. And so I think most organizations that we're talking to are absolutely moving the direction of building out their data foundation and their fundamentals. But they're also being asked to do a lot. The operators and technologists that I'm speaking to are being asked to do a lot. And so I don't think there's a clean answer to that where I can say confidently, yes, every organization is getting the fundamentals into place before touching this. I don't think that's realistic. So what we're seeing is that companies are certainly concerned about those data fundamentals and getting those foundations in place, but are also experimenting and being asked to experiment and also excited themselves to experiment. So I think the answer isn't clear cut, but I also think waiting for perfect foundations, as John described, isn't necessarily the right call. I think experimenting now while strike while the iron is hot, I guess is what I'll say, is a useful practical move.
All right, thank you. Okay, so let's shift and talk a little bit about those legacy systems with Travis. And again, I'm trying to tie in the Q&A as much as possible to make this a live conversation. There's a few questions about what to do if your industrial equipment is bespoke, and I like how someone called it bespoke, right?
Yeah.
It's yeah, proprietary. There's many other words to use that, but yeah, let's talk about those legacy systems. What's the first step to solving that problem? I see inductive as the very bottom of the stack. So we'll go to you to talk about that.
Yeah, no, I think that's a really great question and a really important place to start. Like we talked here a lot about laying the right foundation and the right data architecture. Well, what does that actually mean in practice, right? If you look historically from a SCADA standpoint, what we would have done is have a centralized SCADA and we would go connect to all the controllers that are out there. We'd bring all that data into that system and hopefully that system had the ability to get the data out to other applications, right? Or people that wanted to consume that. And that's a very application approach, right? Versus a data architecture approach, where really from an architecture standpoint, we need to decouple our data from the applications that need to use it. And so that means, okay, if I'm going to do that, my data is the first thing I think about. And ultimately, we've got all sorts of different kinds of data out there, whether it's from, legacy controllers, modern, modern IO or PLCs. You've got, new sensors that are out there that could speak new protocols and get data, out there easily. I mean, when you look at IIoT for a long time, when it first came out, it was kind of a way to kind of bypass the traditional layers that have been in there and the OT layers, right? We want to get data to the cloud directly, put a new smart sensor in, go right to the cloud. And it just illustrates that there's a lot of data out there, and ultimately we want to get that data into a common infrastructure that makes it look the same, makes it accessible, to anybody that wants it. So and it has to be like you have to balance that legacy world with the new greenfield world where you're bringing in new sensors and you have still a lot of old stuff that's out there. So I think edge plays a huge role in that, where we can put something out the edge where we can take data from these controllers, contextualize it, and then provide that to a data infrastructure that these applications can then consume, where we can then look at old and new data and make sure that we're modeling it the right way and being consistent with those models, especially from site to site. And so I think that's a really important part is just have that right architecture. And so that really leads to like that single source of truth that you could have as close to the source of data as you can. Historically, when we looked at like ML for a long time, we would put data into a database, right? So we get data from PLCs, we put in a database that may not been contextualized, just kind of put into like a big database so that we could start using it. Well, what did data scientists have to do? They had to go and clean all that data. They had to make sure that data was actually, representative of what it should be. They didn't even have sometimes the context to know what was the engineering unit of that data, what was the range, what was the expected values. And so I think a lot of that has to be thought of and done once at as close to the source as it can, so that we can clean it there and have the right context, so that we're not having to do that work many layers above. And we all know in this world that we can have a signal that can just drop and it goes to zero. Well, if we start storing a lot of zeros, and even though we didn't have the right data there, that's gonna lead to inaccuracies with our analytics or ML or of course with AI systems. So we've got to be able to kind of address that fundamentally. And I think that the idea of decoupling and thinking about data from an architecture standpoint and having organizations dictate what they want that to be, not having vendors dictate what that is. They need to be in control of what that data product is, as John said. I think it's a great way of looking at it. You do that, you're going to really get to where you want to go, and balance this kind of old and new world.
All right, thank you. And then let's move down the line a little bit to contextualization. And this question is for John. There was a question in the chat that we're talking a lot about data contextualized data. Can we be more concrete here? So I'm going to ask you to work that into your answer. Like what kind of context actually brings value was the question asked by the guest. So why is contextualization such a recurring problem? Why is it important? If you can speak to that, that would be great.
Happy to. So first off, I always think of context is it's in the eyes of the consumer of the data. So each use case may need different context. So for instance, I have a pump on a factory floor. Now, if I'm a quality engineer, I need to know what's the pressure, what is the product that was in, the serial number or the VIN number of the product that was in um, the that work cell when we collected that pressure. I need to know what stage of the process that pressure was collected and things like that. On the other hand, if I'm a maintenance tech, I don't really care about what product was being worked on. I don't care what stage it was. I need to know if the how long the pressure stayed over a certain value, because that could tell me that I need to replace the seal. At the same time, if I'm looking at energy, I'm trying to minimize the energy consumption across our company, or at least understand where we're using a lot of energy. I need to look at the energy and the pressure and how those two are related, and how often am I seeing high energy demands out of that pump, because maybe I need to replace it and buy a new one, or do some things. So we have raw telemetry, but for each case, I need to contextualize it differently. And oh, by the way, a lot of context is stored in other systems. So the maintenance tech uses context out of his CMMS machine system, his asset maintenance system. The production tech is using data out of his MES system. I was talking with an engineer recently where he was saying he's got a machine learning model running right beside a machining center, and the context that they want is from the ERP system, because it knows what the raw material was that went in. And so they need to get certain data, not only the telemetry data out of, say, ignition from the factory floor, but they want to mix that with data out of the ERP system that they've already moved into Snowflake. So it was a, how do I get data out of Snowflake, move it down to that machine learning algorithm that's running right beside um, the work center, the machining center. So, there's data everywhere. And one of the interesting things that people are looking at right now is, well, if I combine this data with this data and that data, then what can I learn now? And so that's all context. And you really, Travis kind of started the context piece, which is, okay, I've got a value. What are the units? What is the value? Is it temperature? Is it pressure? Or what are the units? What's the ranges? But then there's, well, what's the product that we're working on? What's the process that we're doing? What else is happening? How many times have I used that turning center? So there's a lot more data that people want to combine in order to create context. And so, that creates huge opportunities, but that's where people are going when they think about context, is what other data do I need to relate and pull together so that people who maybe aren't on the factory floor know what they're working with. They have a discrete set of data, they know exactly what it is, and they're working on it. Because the last thing we want is every single pump to be publishing into a data lake and no one knows which one they're using, or they're combining data from different pumps into one learning algorithm, and it's not going to work. So context, I started with, it's in the eyes of the consumer, the use case, and so you need to be able to discreetly define that based on what you're trying to do.
Yeah, to just sort of add and summarize what John said, because I think he nailed it. It's sort of the tags themselves, the basic metadata about tags, things like engineering units that Travis mentioned, set points, that sort of thing. But then beyond that, the relationships to other data points, the relationships between data points that sort of describe that. And learning to sort of encode those relationships is a key piece, right? Is one machine downstream from another? Does one process feed a different process? Does that has that seal been at a certain pressure level for a certain amount of time. It's being able to encode those relationships beyond just the actual tags themselves or beyond just the data points themselves. And I think, yeah, relationships are a really key part of that, and something that AI really also depends on. This is a conversation about AI, and a lot of that context today exists in the minds of operators, in the minds of the people on the shop floor. And if we can learn to encode that, then we can again learn to give those operators superpowers, or that data team not having to pick up the phone and call an operator and say, "Hey, what is the relationship between these data points?" Um, Even just the basic semantics of those data points is key, right? I have a automotive customer that I work with that they have 30 tags called IoT underscore data underscore one, IoT underscore data underscore two, and quite literally only the operator knows what those tags mean. That's a lack of context, right? And so some of that context is provided by semantics like the topic hierarchy in MQTT, or the data models that support that, or the UDTs that go around that. And some of that context is in those relationships.
I wanted to mention one more quick thing, which is where we're all alluding to here is this kind of layered approach too, right? There's data with context at different layers as well, and it's how we can basically share that information, and that's going to lead to, of course, leveraging standards, leveraging things that are out there that help us do that, because historically we've approached these things by, okay, at this layer I got this data, and then I'm going to try to like completely transform it and move it into something else that is there not really it's not really the same anymore, right? And so it becomes harder to scale that over time. And so this layered approach, there's a lot of efforts out there, especially with like an organization like SESME, who's trying to help with this, to ultimately build your unified namespace. I know we might be talking about more about that later, but like across organization. And so I just want to mention that it does take lots of it does take products working together and be able to share this meaning so that you can make the most use of it.
I think we'll jump to that a little bit now. So there've been some questions in the chat about what is the architecture? Is there a standard industrial IoT architecture that you're recommending? Things like that. So let's talk a little bit about why those decisions matter. Why does choosing MQTT? And we could spend a whole webinar on these topics. So we'll have to take it for what it's worth with a minute each or so. But why do decisions on things like protocol and design paradigms like unified namespace matter before advanced AI use cases can be executed or even attempted? So let's start with Magnus, and yeah, if anyone who wants to jump in on that one, go ahead.
Uh, I wasn't expecting to start, so yeah, I'll go
Sorry.
from there. Yeah, I mean, I think the protocols certainly matter, but it's about that pattern, right? So MQTT is a great protocol. I think UDTs are an incredible way to encode data models. I think Sparkplug is a really key way for doing that at the edge. I think having a data ops platform is a really key part of this. But beyond that, it's actually the design patterns that matter. Is how do we encode things like context as far left as possible, as far to the edge as possible, so that it's usable throughout the data stream. How do we move towards sort of building with the architectures that aren't necessarily about protocols, aren't necessarily about specific technologies, although of course we choose specific technologies through that process, but it's about the design patterns. And so unified namespace is a pattern that has been widely adopted in the manufacturing industry. Other industries are coming out with similar patterns, or just adopting the unified namespace for themselves. But it's less about the dogmatic approach to a unified namespace and more about actually making those decisions and choosing those conventions, and building out those data models, and ensuring that they're internally consistent, so that that's useful through scale. So yeah, I mean, this is why architectures matter. So we can stop building dashboards and start building decision systems, including encoding things like what is the authority for an agent to do something? What is the auditability of that process? How do we roll back if we need to? Encoding those things in that architecture is really key, and it's not about dogmatically following one architecture or another. It's about figuring out a system and sticking to it.
I think one
Yeah,
thing
Travis
that,
or John, anything to add?
yeah, I was just going to say one thing that we've realized over the last 3 to 5 years is that it's not just about one either. That 5 or 10 years ago, it was let's just move all the data into this one system and it'll solve everything. Um, and that rapidly, and we used to talk about big data, and then that rapidly became the cloud and a data lake. And how are we going to efficiently move it? Well, let's use MQTT and whatnot. But what we're seeing now is there's almost too much data to do that, or there is too much data to do that. You could have nearly infinite data, and you don't need 99.9% of it. So it's about moving the data that makes sense, contextualizing the data in a way so that it can be used, and in some cases, leaving the data where it is. But making it easy to access. And so we've realized that it's not one approach, but there are multiple approaches, whether we're querying data, whether we're subscribing to data, whether we're publishing data, there's lots of different approaches, and you need to understand how, at a high level, how you're going to use the data, what's going on here. Is this an AI agent that wants to be able to query? Is this machine learning that needs 5 years of history? Is this real-time data that needs to be updated, every time on data change? You need to get to that level of definition to start building these use cases out. But once you can define that, the systems and technology exist today, and you can move fast. The key is defining the data you need, defining the use case and the frequency, and then you can move really fast, because whether HighByte can integrate with Ignition and integrate with Hive, and Hive can integrate with Ignition and integrate with Hive. Like, we can move data really smoothly if we have, this is the problem that we need to solve, and this is what we need to do with it. We can, the technology is there now, but we do need to get really precise on what we're doing and why.
Love that answer.
Yeah, I'll add, when you look at, it's really important, right? When you're looking at building your systems to do it the way that makes the most sense for you, as John and Magnus were saying. There is no clear cut, here's how you do it. Here's the best practice. This is the best way, here's how UNS is done perfectly. That it's work in progress. There's a lot of smart people figuring this out right now and figuring out how they're going to put it together. But I can say that, like, if you look at MQTT as a protocol, it has fundamentally transformed how OT works. Historically, we would connect, especially in certain industries, connect to these devices over telemetry networks, and we'd have to, poll these devices and have to have sophisticated polling, programs put in place, schedules put in place to be able to do that, and or there were scaling issues because, we had wanted to pull data faster, and could we do that from the systems we had? And we went to a place where, there was brittle, slow, you didn't get the response you needed to then leveraging MQTT to just make everything more accessible, more scalable, faster, more reliable, especially remote operations. I mean, it's fundamentally changed how we transport industrial data. And that's one layer of it, right? We need to get data to these systems that we can then build relationships on. But then we want to take advantage of those relationships and get it to another system where they can take that and go further. And so it's really that, like as John was saying, that approach, right? And that layered approach, and what makes most sense? What are you trying to do? Because there's a lot of different protocols, a lot of different things that we could be doing. And it's not like a versus, it's like, what is the right thing for you?
All right. With that, we'll shift a little bit to use cases. Thank you. So when organizations talk about AI value, they're pointing to a familiar set of use cases. And I think all of us on this call have been in this industry for a while. And as I read the survey results and thought, oh, okay, they want to see predictive maintenance, OEE, those are not new, those are not new use cases, right? Reduced downtime. What's interesting is these things don't appear all at once, right? They usually show up as a progression. Teams start by monitoring what's happening, then they move to optimizing performance, and eventually they can create closed loop decision-making processes. So I want to ask the panel, and we'll go to some Q&A because a lot of those have been around use cases, like what you've seen teams successfully doing to move along that path, to move from those, earlier simple use cases to the more advanced ones. And Travis, I'll start with you, and like I said, then we'll pull in as much Q&A as we can here in the next 10 minutes. So, where do you see teams getting the most early value? Like, what's a realistic use case to start with? You alluded to some of these already in our call, but if you can dig into
Yeah, I
that.
mean, there's a lot of places to think about, right? And what's interesting if you look at a lot of like search engine results, still like number one search, is still for things like OE, right? And how to put that in place. So is it, people think like, oh, it's that's to solve a problem. Well, for some people, but not for everybody, right? And so because we still have a lot of systems that are old and don't have the data to able to do that. So I think there's still obviously a lot of validity to being able to get those systems in place. When you look like beyond that, ML still has a big stake, and not everybody's taking advantage of ML. And there's like some great opportunity, especially with anomaly detection, that's way more accessible and easier to do. We can throw in a lot of data and start getting some predictable results out of that. There's even a little bit of forecasting that can happen if you choose the right model. So I think that's an interesting use case that you're not seeing a lot of people talk about, but ultimately is pretty easy to get started with. And then you get to like when you look at AI, for me, I think as I said earlier, being able to help augment operators. To be able to ask those questions and quickly, they stare at these big screens, right? We built these massive screens, and especially in operator rooms, there's all sorts of information on there, and they have to make heads or tails of it. But well, we're in a world now where there's a lot of people moving around and new people coming in, new workforce coming in, and they have to learn these systems and get up to speed really quickly. And I think AI can help in that way if you do it right, responsibly, right? Because as you said, garbage in is garbage out, right? But I think there's a lot of being able to have an issue happen and then put your responses as to how you solve those problems so that it can even help you the next time to do that faster. Is a big area. So those are kind of I think it's a pendulum, but you got to start small, and you can. Those are, I think, some of the use cases that are pretty exciting.
Thanks, John. I'll ask you the same thing, and I'll twist it a little bit. Just yeah, what specific use cases do you see that are reusable, right? So I think there's a lot of point solutions, point problems, but what are some of the use cases that you're seeing at HighByte that don't have to be rebuilt every time that can really be scaled and used across the business?
Yeah, I mean, I think you started off with the right comment that the common use cases are predictive maintenance and OEE and improving quality and energy usage. And geez, manufacturers have been working on those since before any of us were born, and will continue for the next 50 or 100 years working on those things. It, Part of it is, which is where I think Travis was also going, is where are your problems as a manufacturer? Like, do you have a problem where lines keep shutting down? Well, then maybe we have a maintenance issue or we have a production issue and we need to dig in on that. Or do you have a problem where you're spending too much money on energy? Well, let's start monitoring energy consumption and see if we can reduce that. So part of it is the specific use case is in the eyes of the manufacturer and where they see their challenges. I think there's a simplicity measure to these use cases as well, in that predictive maintenance tends to be relatively simple because you're only collecting data from a single asset. When you get into OEE, you're collecting data from multiple assets across a line, and lines can differ, and so it becomes more challenging to run standard collection metrics. And then you get into use cases that are almost a broader team. So first, it's a broader um, data computation challenge and collection challenge. And then you have a broader team. Like, we're seeing a lot of use cases where the quality team or the design engineering team or the supply chain team would like to get access to data. And in the past, they've never had access to it. The operators did, but the quality team didn't, or they would get, inspection reports once a week. So um, we see kind of that complexity and then breadth of user use case and almost like organizational complexity as how most of our customers are evolving. But ultimately, they all have very broad visions of what they can do, and we think there's lots of opportunity for them to improve.
Thanks. Okay, one more question, and then I think we'll leave you all a moment to give a final word. So, Magnus, this one's for you. There's actually several questions about machine learning as a use case. So, one is, can we discuss machine learning specifically and how the panel sees its application on-prem in the OT space as a first step, all running on a UNS? So, if you can tackle that in 2 minutes.
Yeah, no, I think it's a very apt question. Look, we talk about AI, and most of the time when we say that word today, most people think LLM. AI is very much also machine learning, and it's a key piece of this. I particularly think that moving ML closer to the edge and being able to take those decisions in real time is a key first step for a lot of organizations. Specifically, you know, it has much higher determinism. It has much higher consistency. It's going to breed confidence much faster. It's going to develop some of those skills. It leverages that fast-moving contextualized data. There is incredible use for machine learning. By the way, not just anomaly detection. I think Travis, that's a great call out as a great place to start. But also we're seeing a huge amount of work being done around machine vision, whether that's for safety applications, for quality applications. I think there's a ton that's happening in that space. One of the reasons I specifically love machine vision is that data is difficult to move, right? If I'm taking 10 megabyte images, if I'm taking 10 megabyte images per second across a facility, that's my entire bandwidth for that facility. So moving my entire external bandwidth for that facility. So moving some of that to the edge and not attempting to process that in cloud is it's not just a nice to have, it's a must. And so, yeah, I think realistically, machine learning is a great first step. I don't want to discount large language models or agentic AI. I think there's a lot of the upside there is really to be discovered, but machine learning is an incredible first step. And again, that consistent data foundation, that contextualized data is really key for that, right? You know, uh, um, I'm going to forget my words here for a second, but understanding what part of a process I'm in is really key. So John was talking about what part of a process being part of the context. I can't do anomaly detection if I don't understand what part of a process I'm in, because I don't know if that's a shutdown event or a stoppage event. But if I understand, if I've encoded what part of a process I'm in, I can now actually start to do machine learning over that. So again, that context is incredibly important to machine learning. The unified namespace, if that's the direction a customer has gone, is incredibly important for machine learning. And of course, just helps you to get closer to other forms of AI when you're ready for it.
Yeah, if I can make just one quick comment, which is with machine learning, historically, you would have shipped this data off to the cloud and kind of train your model and then run it back at the edge potentially, right? With computation where it's gone now, we could do all of that on site, right? Like so, it's and to be able to train models, right, and keep retraining models and then using it all, to reduce latency and all of that. It's way more accessible now than it has ever been. So if you're not looking at it, you should.
Yeah, and I think
Thank
the
you.
future is if we can get AI agents to utilize machine learning when it needs to run calculations, and then you can deploy that easily and quickly. Like machine learning 5 or 10 years ago took a lot of work, a lot of effort, a lot of deployment time and collecting data and everything. We can shrink all of that now with by combining machine learning with LLMs, with agents, and putting all that together all of a sudden, and using containers and using all this new technology that we have available in from the IT world, that we can deploy that much easier at scale, and it can get really specific to a specific machine center or image camera and things like that. So a lot of that's just so much easier now.
All right, thank you. Lots of other good questions in the chat. We always do our best after the webinars to address those questions individually. So we will work to do that. The recording will also go out. We've had lots of questions about that. So just last, I want to give each of you a chance to say one more thing, and then we'll wrap up. So one sentence. One sentence is all you get. What's the single most important data investment that leaders need to make in 2026 to accelerate their AI use cases? All right, let's start with, I think I promised I'd start with Magnus, so hopefully you're ready and had enough
All
time to
good.
think.
Yeah, I'm good. I mean, I think the answer is AI scales when the data foundations scale, and architectures matters because they enable reuse. I think that if I could give one message to everyone, it's think about the architecture because that's what enables reuse. Think about scaling the foundations because that's what enables you to scale your AI.
Travis.
That's a great answer, but on top of that, I'll just say driving culture, right, around this and making sure that everybody's aligned with how the business wants to approach these technologies.
And John.
Yeah, I think both of those are great answers. That it's um, thinking about the day, making data a first-class citizen, and thinking about data products for use cases, and then finding great solutions to deliver it.
All right, thank you. I think we could make this a series. Really great conversation. Lots more that we could have talked about. So maybe we'll do it again in 6 months or so and talk about how the use cases are progressing and what we're seeing with some of our customers. So thank you so
The
much
world
all
will
for
have
joining us.
changed.
Great.
The world will
Thank
have
you.
changed. Yeah, completely different stuff in 6 months. Thank you so much. Thanks for joining us.
Thanks for inviting us.
Thanks.
See you later.